Hi, welcome to another 4AC learning video. In this video, we want to look at example 2.5a, which is found in your lecture notes. It goes as follows. For the circuit shown in figure 2.5a, find the unknown voltage V2 and in polar form. So we are given two waveforms, Vt, the main voltage waveform, and V1, the voltage waveform across the first load, but we want to find V2, which is the voltage across the second load, and both loads are in series. So this is a good example of how LTEC theories are going to be applied in 4AC. Let's see how we do this question. Alright, this question we can use Kirchhoff, right? Using Kirchhoff voltage law, Vt is equals to V1 plus V2. So it's a good question for phasor addition. Or another way to put it is the V2 will be Vt minus V1t. So the first thing we need to do is to convert Vt and V1 in the time domain over to the phasor domain. So Vt is equals to 15 divided by root 2 to convert it to RMS with an angle of 40 degrees. Whereas V1 is 8 divided by root 2 at an angle of minus 25 degrees. So since V2 is Vt minus V1, we have to convert this to the rectangular form instead of the polar form. So for the rectangular form and polar form, let's do the conversion. First we look at 15 divided by root 2. That gives me 10.607. So 10.607, we convert this to rectangular form. So 10.607 at an angle of 40 degrees. That gives me 8.125 plus J 6.818. Okay, the other one is 8 divided by square root 2 is 5.657. Okay, 5.657. Shift, change to rectangular. 5.657 at an angle of minus 25 degrees. That gives me 5.127 minus J of 2.39. 2.391. Right? But we must remember this is minus. So is this whole thing minus from this whole thing. So we have V2 in rectangular form, right? It's 8.125 minus 5.127. That's 2.998. And 6.818 plus 2.391. That's 9.209. 9.209 plus 9.209. Okay, so now I convert this back to the polar form. Polar form is 2.998 and 9.209. That's 9.679 at an angle of 72.07 degrees. I should call this vote, so this is my answer. So now the next thing I need to do is to convert this to the sinusoidal waveform. Right, sinusoidal waveform. Here is the RMS value, so I need to get it back to the peak value, multiply by √2. Sine, same frequency as the other two waveform, and then plus an angle of 72.07 degrees. So that will give me 9.679 times square root 2. That's 13.688. Sine of 314t plus the angle 72.07 degrees. Okay, so that's my answer for the sinusoidal waveform. Alright, so this is a simple example of how phasor addition and phasor subtraction is used in AC circuit analysis. Thanks for watching this video. I hope you have learned something from this video. Bye bye.